Good morning, class.
Good morning, sir.
Please, how you guys doing?
Yes,
We are fine.
We thank God. Okay, so please, I'll start the class in the next few minutes. But please make sure you get yourself calculator wherever you are, because I'll be asking you to calculate one or two things today. Okay, so please
Okay, sir.
make sure you get yourself calculator, and then when I ask you to do it, you do it yourself. Okay,
Okay, sir.
and then I believe if you took time to watch the video, the slide that I sent to you guys concerning today's class. Did you guys watch the video? Did you watch the video? Okay, nobody's responding. Okay, so um, we are going to learn what we call how to calculate the sample size. So in our previous studies, we learned that it is from the population that you get your sample, and from the sample we're able to generalize for the whole population. And so we've learned how to get a sample that's making good use of the sampling techniques. That's what we learned last week. So today we are going to learn how to calculate the sample size. Okay, that's our objective for today, to learn how to calculate the sample size. Okay, so now, as I said earlier on, I would prefer you get yourself calculators there, then you practice. Okay, so in order to calculate your sample size, there are some basic things that you need. So the first thing that you population size. Okay, you have to determine your population size. So the moment you determine your population size, that means that you have one thing. It's like let's say preparing preparing a soup. There are some ingredients that you need. So the same thing goes for the sample size calculation. There are certain things that you need for you to be able to calculate your sample size. Okay, so the first is the population size. The moment you get your population size, then you determine what we call the margin of error. The margin of error. So the margin of error, just it's the error that you, the researcher, you are willing to make. Hello? Okay, so the margin of error is always set by the researcher. You, the researcher, you set your margin of error. Okay, you, the researcher, always set your margin of error. And this margin of error, nobody will come and tell you that use this margin of error or that. So the margin of error is the error that you are making room for. So for example, let's say I'm doing a research on, let's say, uh, perception of biostatistics in class. And after my research, I found out that 60% of the class are interested in biostatistics with a margin of error of, let's say, 5. So it means that if I come and do this research again, someone is giving us feedback. Let me check this person. I think he has muted himself. So if I come and do this research again, it means that I'm likely to get something within 60 plus 5 or 60 minus 5. That's the margin of error. And once you are estimating, there's always a margin of error. You have to make for that error. Okay. So the next is to get your margin of error. So if you get your population, you get your margin of error, then the next is what you call the confidence level. The confidence level. Okay. So the confidence level will just tell you you are assigning a value. Okay. You are assigning a value that is associated with how confident you are in whatever you are doing. Okay. So if you are calculating the sample size, you, the researcher, as I said, the confidence level, you will choose it on your own. And you are assigning value to how confident you are that whatever you are doing is going to be accurate or will be within the margin of error that you are estimating. And I keep telling my students that the confidence level is in line with the margin of error. Okay. So you determine that, oh, okay, whatever that I'm doing, I'm confident that I'm going to get this, I'm going to get that. So you will choose your margin of error. Nobody will come and tell you to choose it. But in most cases, we use confidence level. Use a confidence level of 95%. Use a confidence level of 95%. That's most cases. Yeah, it's about let's say 95 out of 100 get these research or most of these researches using 95% confidence level, and at times you get 99. So most times you use the 95 and 99, especially when you are dealing with health related research. And don't forget, I said that you have to choose your confidence level. Okay, you have to choose your confidence level. Nobody will come and tell you to choose this confidence level or use this confidence level. You as a researcher, you choose your confidence level. Okay, so it is up to you determine confidence level. That is, if you remember, when they were producing this vaccine, the COVID-19 vaccine, it was a point that some of the manufacturers were saying that yes, it's 95, others were saying 99, others were saying 90 here and there. You get it? So you have to choose it. You have to choose it. So the next thing that you also need is what we call the standard of deviation. This is not standard deviation. This is standard of deviation. The standard of deviation. So for the standard of deviation, it tells you how much that you are going to have variation in your results or in your research. Variation that you are going to have your results or your research, or the percentage or the amount of individuals that are experiencing that phenomenon and those who are not experiencing that phenomenon. And that's what we call the standard of deviation. So for example, again, if I'm to check if students are interested in biostatistics, I can go by, let's assume that I have, from previous research, it is perceived that 60% are interested in, and then 40% are not interested. So it means that the standard of deviation is going to be 60-40. So that 60 are those experiencing that phenomenon, or those who are interested in biostatistics. And normally we represent those who are experiencing that phenomenon by this guy, P, letter P. We normally represent it to letter P. And those who are not experiencing it is always 1 minus P. 1 minus P. But in research, it's not easy to identify this standard of deviation. So most cases, what we do is we just split it. Okay, before you do that, you just split it. You are going to split it and say that, oh, okay, 50% are you interested in biostatistics, So then that means that this would be 0.5. And then 50% are also not interested in biostatistics. Okay. And that means that the 1 minus P will be 1 minus 0.5. Okay. 1 minus P is equal to um is equal to 1 minus 0.5. Okay. And that will give us 0.5. So to be on the safer side, most cases, researchers will split it. We will just split it. 0.5, 0.5. Okay. And that's what we do most cases. Because it's not easy. It's not easy to determine that uh, this percentage are experiencing it, this percentage are not experiencing it. But if you are fortunate, and probably there is a earlier research that has that information, then you are good to go. Okay. But in real life, it's not easy. Not easy. I think the last thing that you need is what we refer to as the Z-score. But the Z-score is always and always and always, please keep in mind, it's always associated with your confidence level. The moment you choose or you settle on your confidence level, then that confidence level will call for its respective Z-score. Please keep in mind. So it's like what you guys do, this thing, your mashup, where you are buying data. So if you pay 10 CD, its respective mashup will come. Do you get it? So if you buy 20 CDs, its respective mashup data or voice will come. So the same thing goes for the confidence level. The moment you choose this confidence level, then you call for its respective Z-score. Okay? Then call for its respective Z-score. The moment you get that Z-score, you are good to go. Okay? You are good to go. So now, let's continue. Let's continue. So now let's assume that someone is using 95% confidence level. So the moment you settle on 95% confidence level, its respective Z-score is 1.96. And to be frank with you, the 95% confidence level and that of 99, that one I know it by heart. I know it by heart. Because I've been using this thing most of my research. Okay. So the more you use it, the more you are able to recall. But it doesn't mean that you need to memorize this thing. In research, if you are doing your research, uh, if you can't recall, you just search, you get its respective Z-score. But in most cases, as I said earlier, we use 95% confidence level. And in fact, if you are doing health-related research, we're going to use 99% confidence level. Okay. So these are some of the things that we do. Okay. These are some of the things that. So if I settle on 90% confidence level, its respective Z-score is 1.65. If I settle on 80, the respective Z-score is 1.28. As I mentioned earlier, in health-related research, we use 95% confidence level. Okay. Now, I think we can now start with the calculations. So please, wherever you are, I want you to get your self-calculator. We'll do this thing one at a time, one after the other, one after the other. Then we settle on the final answer. Okay. So what I'll do is probably I'll pick just two of you guys to calculate it for me. Okay. Just one person to be punching it on the calculator, Okay. So now the first thing is what we call the, okay, let me just pause. I think if you have any question, let me hear from you. If you have any question, please talk to me. Please make it brief because today we have a lot of competitions to do. Please make it brief. Faustina, Talk to us.
Sir, good morning.
Good morning.
Please, I want to know if the Z-score is standard.
Exactly, it's standard. So you don't need
Oh,
to do any
okay.
computation.
There is no calculation
No, no,
for.
no, no, no.
Okay, okay,
The theory is there, but
okay.
but I'll not bother you. Just the calculation.
All right, all right. Thank you.
Mm. Okay. Can you continue?
Sir,
Sir,
please,
please,
what
there is a
about the
hand up.
confidence level?
Okay, go ahead. Go ahead, please, hurry up.
All right,
Sir,
please, very, let's hear from you.
sir, please, what about the confidence level? Is it constant?
I didn't hear you.
Please, the confidence level, is it constant?
No, which one are you referring to?
That
Which
is the
parameter?
margin of error.
No, the margin of error. I said that you have to choose it. So you as a researcher, you choose your margin of error. It depends on you. So if someone may use 5%, that is 0.05. Someone may use 3%, 0.03. Someone may use 10%. It depends on you. You will choose it. But for exam's sake, I will choose the margin of error for you guys. The
Okay,
margin
sir.
of error and then the confidence level. For exam's sake, if I'm to ask you something on this, I'll choose it for you, because if not, you guys probably everybody will choose his or her own, and the answer will vary, and that will be difficult for me for
Okay, sir.
setting up the marking scheme. Okay.
Okay, sir. Thank you.
Okay. Next, please, hurry up.
Hello, sir. Please,
Yes.
with the margin of error, is there a range that you choose from, or you can choose any figure at all?
You can choose any figure. That's why I mentioned that it depends on you, the researcher. But don't forget that if the margin of error is so large, people will start questioning your output. Okay. Any other? Deborah, please hurry up, hurry up. Deborah, are you there?
Sir, I'm asking of the Z-score. That one, so are you going to choose for us?
Choose one.
The
Are you talking
Z-score.
about the exam sick?
The exam sake, how are you going to get the Z-score?
The Z score, as I said, for exam sick, I will give the Z score. But if I choose the confidence level, the respective Z score, you have to call the respective Z score. So that shouldn't be a problem. But in real life, you can even search. If you choose a confidence level for one, let's say 95%, then you search for the Z score for confidence level 95%. You should get it. But me, as I said, I've been using it a lot, so I can recall it. The moment I settle on 95, I know it is 1.96. The moment I settle on 99, I know it's 2.58. So the more you use it, the more you're able to recall. Okay. I hope I've answered you. So now let's continue with this calculation. So we are going to learn 3 formulas today. So this is the first one. So for the first one, is let's say what we call we have standard formula. This is the standard formula. And if you look at the formula itself, you can see that this formula depends on the population size. So it means that If you don't know the population size, you can't apply this formula. I hope that is clear. Now we know that capital N stands for population size, Z stands for the Z-score, E stands for the margin of error, and P standard of deviation. Okay, so now let's put in some values and see how you calculate it. Okay, so I want you to look at this. Look at this one. So we have a Z-score of 2.58. So Z-score of 2.58 means that we are using a confidence level of what? Can someone tell me the confidence level that we are using here?
99.
Good, good. So we are using a confidence level of 99. And we have a population of 425. The margin of error that we are using is what? 5%. And then the P is 0.5. Okay. So now we just put the values in the formula. We are just putting the values in the formula. Okay. So this is where probably you find yourself wanting. Please, I would advise you that don't try to feed everything to the calculator. Okay. Don't try to feed everything to the calculator. Do it one after the other. So now I'll prefer that we work the top. I'm not going to talk about the numerator and denominator. I'm going to say top and down. Okay. So we are going to work the top, this one first. Whatever you get, then you come and work also this one separately. So then the moment you arrive at these values, then you can now divide to get your sample size. Okay. So that's what we are going to do. So I want one person to volunteer. The person should get calculator. And whilst you guys are there, I expect you to also do that. Let me call, I think, Obin, are you with me?
Yes, sir, I'm here.
Okay, so I'll prefer to work with you, okay?
Okay.
So now, the moment you have, this is 2.58 squared, that is the Z-score, the Z, 2.58 squared. Please take care that 2.58, if you are typing on your calculator, don't go and type 2.58 square like this. If you type it like that, the system is likely to square only the 8 and ignore the others. Okay, so what you have to do is you will then need to put everything in bracket like this, then you get your answer. Okay, that's the first option. The next option is, because we know that any number square is the number multiplying itself. Okay, so
Okay,
I can say that 2.58 times 2.58 will give me 2.58 squared. Okay, I hope that is clear. So as I said, don't try to feed everything in the calculator. So now I want you to type 2.58 times 2.58. What are we getting? What is the answer?
6.6564.
Okay, 6.6564. Okay, good. So please keep in mind, it's always advisable that you work with at least 4 or 5 decimal places. Okay. So it means that we are done with this guy. Now, the next is you have to remember board math. So it means that you need to do the subtraction first. Then you come and multiply by 0.5. So 1 minus 0.5 is what? Please listen. On this time I'm not going to write it. 1 minus 0.5 is what?
0.5.
Good. And so now we have 0.5 here. So we are going to multiply this 0.5 by 0.5. And that will give us what? What?
0.25.
Are you sure? Okay, 0.25. Thought this is what I'm going to write. Okay. So that will give us 0.25. So it means that we are done with this guy. Okay. Are you with me?
Yes, sir.
Yes, sir.
Yes.
So now we can now divide it by 0.05 square. And 0.05 square means that we are going to multiply 0.5 by 0.5. Please, wherever you are, take your time, listen to me and practice over there. Okay, when I'm done, and then you come and ask questions, I'm not going to go over. So please listen. That's why I've taken my time and I'm doing it one after the other, which I expect you to do the same thing. If you are doing it for exam's sake or probably in real life, your research, no rush, okay? So again, once we are done with the top side, this side, the one that I've canceled, this guy, we are done with it. So now we are going to work on 0.5 squared. 0.05 squared means that we are going to multiply 0.05 by 0.05. And that one will give us what?
0.0025.
0.0025.
Okay, so please, my sister, you can try there, but I want the guy to talk, please. Okay. So that is 0.0. Come again.
0025. 0.0025.
Good. Good. So now, what we can also do is, now that we have this, that means that we are done with these guys. Okay. So this is equal to, so now we are now going to multiply 6.6564 by 0.25. And that will give us what? 6.6564 multiplied by 0.25.
It's 1.6641.
1.6641. Thank you. Divided by 0.0025. So now I want you to divide 1.6641 by 0.025.
It gives us 665.64. 665.64.
665.64. So now this is the final answer. So it means that everything here, let me try to, so it means that now everything here is equal to what? 665.64.
5.64.
0.64. 0.64. So it means that we are done with the top side. Okay.
Yes, sir.
My brother, there's a hand up. Let's listen to that person, then we continue. Then we come and work this side, the downside. Okay. So let's call that
Yes,
person.
sir.
Deborah.
Deborah, you can unmute and speak.
Sir, I was asking, can you multiply the 0.05 square, which is 0.0025 by the 425 before you divided by the
We are not there yet.
1664?
Please. We are not there yet. So
Okay.
take your time. We are moving step by step. We are now done with this guy. We are done. So we are now moving on to the next one. Okay.
Okay.
Okay. So now let's continue, my sisters and brothers. So it means we are done. So I can clean this side. Okay. I'm cleaning this side. Okay. So now let's continue.
Bye.
Hey, your people are worrying you. Sandra, the free Sandra, your hand is up. Please talk.
Sir, please, I wanted to ask, you see, when we we got 6.658, we got 6.6564 from 2.58 square. So please, I wanted to ask that do we have to write all the answers, or we can just write some of it, like 6.66 or 6.7, instead of writing all the 6.6564.
I remember I said that at least it's advisable you work with 4 decimal places. I mentioned it. It's always advisable you work with 4 decimal places. Okay, so now let's move on. Okay, so now you guys can see that. You can see that everything here, everything there is the same guy here. I hope you can see it. Can you guys see that? Hello? Where is the class? Okay, let me call.
Yes, sir.
Yes, sir. Please, we can see.
Okay. So if you can see that, then it means that 2.58 squared is what we had here. But for the doubting Thomases, I want you to type again. You type 2.58 squared. That's 2.58 times 2.58 is what? What are we getting?
It gave us 6.6564, just as we had in said.
Exactly.
Yes.
And this means that we are going to get the same thing here.
0.25.
That's 0.5
Yes.
exactly. And we have the same thing. And then the 0.05 square, that is the margin of error, is what we have here. Do you agree with me?
Yes, 0.0025.
Exactly. Exactly. And so then I can write this. Let me delete everything here. Then it means that the downside, I can now put everything here like this. Okay. Then I can come and multiply this by 4. Let me just open the bracket a little bit bigger. Let me choose different color so that people will see the difference. Okay. So it means that we have this up to, we have these 3 guys here. Okay. So now I can now say that this times the 425. Okay. I put everything in bracket plus what? 1. Do you agree with me? Do you guys agree with me?
Yes, sir.
Good. So now let's do the computation again. So we can say that 6.6564 times 0.25. Okay, that one. So it means we are doing the top of this. And that one give us what? So now I can say that this is equal to, let me write the equal sign here. 1 plus in bracket. So now let's multiply. 6.6564 times 0.25. That'll give us what?
1.6641.
1.6641. Good. Oh, this is 1. This is not 1. Okay. Divided by 0.0025 times the 425. What are we getting?
1.0624.
Good. Good. 1.0624. Good. So now we can now divide. So now we can say that this is equal to 1 plus. Now we are going to divide 1.6641 by 1.0624. I hope you are clear now. What are we getting?
So it's 1.0625.
Okay, 25. Don't worry. It's this
So we
1.6.
are getting, for that, we are getting 1.5662.
So when we
So
divide,
four decimal places.
good. So
1
when we
point,
divide, please let me write.
okay,
You listen to me. So when we divide 1.641 by 1.0625, we are having what?
1.5662.
Mm-hmm. Okay, 2. Good. So if we add them, now we are moving to this side. Okay, please. We are moving to this side. So if we add 1 plus 1.5662, that will give us what?
2.5662.
Good. So it means that everything here, that's the answer. So now I can now bring this number here. I hope you guys agree with me. Now I can now divide this by 2.56662. Agreed? Do you agree with me?
Yes, sir.
Good. So now divide it and let's see what we are going to get.
So we are getting 259.
So let me choose different color. 5, 9, point what?
9.3874.
74. So if you run into the nearest whole number, you are getting
The
what?
nearest whole number 259.
259. So this is your final answer. So this is your sample size needed for your research. So you see that it is very simple, but the problem is at times you guys want to put everything in the calculator, then you go your way. And that's not how it works. Okay? Okay?
Okay, sir. Okay, sir.
So please, when you are doing it, take your time. Okay. So now,
Yes.
any question? So I think I can clear everything. Show the slides to you. So if you have a question, then so let's see if we have the same thing on the slides. Let's see if we are getting the same answer. Good. So we also have 259. You see, the final answer is 259. Okay. Do you have any question? If you have any question, my brother is here too. Okay. I think there's a hand up. Can we call this person?
Sister Mary, kindly unmute and speak.
Okay. So please, mine is, can you please go over just the down part for us, just the down one. I got confused along the line, please. For the
No,
upper one.
be specific. Be specific. Which one? Where was the confusion? Look at it. I hope you can see the screen, right?
Yes.
So you need to square this one. You need to square it.
Mm.
So as we did, you need to square this. So what we did was, you see that everything here is the same guy here. 258, 258, 0.05, 0.5. 1 minus 0.5 is the same thing there. Okay? And then the 0.05 square, this is square. It's not 0.052 square. So the 0.05 square is the same guy here, 0.05 square. So what we did was, whatever we got for the top this side, that was 6 point something. I can't recall. Right, so that was 6.564. So you see that we still have the 6.6564 here, because it's the same thing, times the 0.25. Okay. Then you can square this 0.052. Okay, and that will give us 0.025. So you multiply the 0.025 by 425,
25. Okay.
and then you get this.
Okay. Yeah.
So the moment you get this, you can now multiply this. You multiply this one, and then that one gets 665.64.
Okay.
Okay, so whatever you get, you can now divide. Okay,
Okay, sir.
so when you multiply this, whatever you get, you can now come and divide this. Then whatever you get, you can now add it to 1 before you come and do the final division. Then we arrive at the final answer.
Okay. Thank you, sir.
Priscilla, ask your question.
Hello, sir.
Yes.
Sir, please, the final answer. How many decimal points should it be?
Oh no, I mentioned that running to the nearest whole number. But let me just chip in this. The nearest whole number. If you are running to the nearest whole number, what would be the nearest whole number, my dear?
Okay, it will be 259.
Good. But if I am doing this research, if it's human beings, I will use 260. But it doesn't mean that you cannot use the 259. You can use it, but me, if I'm dealing with, I'm assuming that these are human beings. So who is just 3.39? You don't have any human being who is 3.39. So definitely I will add 1 to it. But it doesn't mean that you cannot use the 259. In fact, you can use the 2. In fact, that's what people do in research. They always run the nearest whole number. But I will just use 260. Okay, and then justify why I'm saying 260. Okay, but wherever you are, I would advise you always run into the nearest whole number. Okay, because
Okay.
any other?
Sir, please. Sister Veronica, Mensah's hand is up.
James, I mean,
Hello, sir.
yes.
Please, can we
Please
have
ask your
another,
question.
please, can we have another example to work on?
Yeah, I have another example, but that's
Sir, please, you are muted.
I said I have another example, but that is for another formula. So what
Okay.
I will say is probably get examples online, because
Okay.
normally I'm time bound. You get it?
Yeah.
Oh,
And please, another question
I'm
is,
time bound. I need to finish what's expected of me in a day. I hope that's clear.
yes, please. And please, another question is, during exam, please, will the numbers be given so that we substitute it into the formula? Please, you are muted.
Yeah, please, I'll attempt to give you something. Okay.
Okay, sir.
Yeah, let's come again. You said in the exam, like
Please, will the numbers be given? Like
which
the
numbers are referring to?
size, the z-score, the margin of error, and the standard of
Yeah, I
deviation.
mentioned that for exam's sake, if I'm to ask anything on this, I will just give the hello. I was muted, right?
Yes, please.
Oh, so what I was saying is as I said, I'll give you the confidence level and then the margin of error for exam's sake. But in real life, you have to get it to your own. Okay. But I said that you will not get the value just like this one that I just fish it out for you just like this. This one is for illustration purpose. That's why this is but in the exam, what I do is I'll give you a scenario. Then you need to fish out the population size. So I was saying that probably I can say that you are part of a research team, let's say a research team conducting a research on malaria, and then as a biostatistician, you have a population of, let's say, 500. Then the team lead advised that he wants a margin of error. He's going to accept an error. He's going to accept an error of, let's say, 10%. And he's also confident that this work should be 90% accurate. So calculate the sample size needed for this research. So you see that this one, you will need to identify these things. I hope that's clear.
Yes, please.
Okay.
So we always have to know our formula, like in our mind.
Which formula?
The formula to be.
Oh, my dear. The first day I told you that I give formulas to students.
Okay,
I remember I said it.
Okay.
Yeah. But it's up to you to know that this formula is used for that, this formula is used for that.
Okay. Thank you, sir.
Any question? I think we can continue.
Hello, sir.
Yes.
Sir, please, with the calculation of the 0.05, when I multiply 0.05 by 0.05, it gives me different answer instead of the 0.0025.
What answer is it giving you?
When I multiply, give me 1 out of 400. So when I try to convert, it gives me 2.5.
No. That means your calculator is not in the right mode. How did you convert it? So the problem is from your calculator. It's not so take your time and get it. Okay.
Okay.
Hello.
Yes.
Good morning.
Good morning.
Please, I was having problems, so I joined late. Please, could you please repeat the calculation?
I will not. You joined late. So what do you want me to go back, please? I've done a lot, please. This one, forgive me, I can't go back. So it's better. What I will do is, what I can do for you is, that's why I sent the video. Please take your time, watch the video, and you have a challenge, you can contact me. But please, I can't go back. I've spent almost 1 hour. I can't, please. Forgive me, okay? I can't go back.
Okay, thank you.
Yeah. But you watch the video. If you still have challenge, that's why I said if you still have challenge, you can contact me, then I sort you out. Okay.
Okay.
So let's continue. We have 2 more examples to work with. So that one too, I expect you to try over there. Okay. I think I saw a hand up. There was a hand up. Can that person talk? Then I continue.
Yes, sir. Hello, sir.
Yes.
Hello, sir.
Yes, I'm listening.
Yes, the time you were trying to state the kind of questions you said, the scenario, I didn't get it well. I think my line was breaking. I don't know.
Oh, that's it's okay. If you didn't get it, that's just a scenario.
That's
no
fine.
problem.
Thank
you. Okay, Emmanuel, please. I think after Emmanuel, I'm not taking the question and continue for the next example.
Okay, sir, thank you. Please, the margin of error, the margin of error, when you listen to other researchers on TV, they mention the margin of error. In your explanation, you said that when the researcher, let's assume the margin of error is plus or minus 5. It means that when the researcher comes back to do the research again, let's say the researcher should find a plus 1, a plus 5 or minus 5 of that. Just opposing that with what I listened to those Imani Africa people and those research people. My understanding was that the margin of error was that you are going for a fact-finding mission. So let's assume the responses that the people will give you some may not be accurate. And that was my understanding of the definition for the margin of error. I don't know if you can clarify that a bit.
Okay, so because of this inaccuracy, that means that if you do it, you are going to either add more values to it, that's where you are getting 6.5, or less value to it, that's where you are getting 55.5. So that means that you are still in that range. And that's that's what it means by the inaccuracy based on the result that you get. I hope that's clear.
Oh, okay. Thank you.
Okay, so now let's move on. Okay, so now let's move on to. So this is also another formula. This one is very simple. And normally this is what I use a lot. So this is for a population where you don't even know the population size, or probably it's very large. So it's even difficult to identify the population size. And you can see that this formula does not depend on the population size. I hope you can see that. You can see that this formula does not depend on the population size. Okay. So this one, you need your margin of error, you need your standard of deviation, and then that of the z-score. So this one, I think this will be very simple for you, right? So now we have a z of 1.65. So this z 1.65 should tell you that which confidence level are we using? Which confidence level are we using here?
90.
90. That's good. So it means that this one, too, as I said earlier on, we just have to take our time and do it one after the other. So this time around, I want a lady to volunteer, and then we work on this, okay? All the guys here. Okay, Naomi. I think I see Naomi. Naomi, can you
Yes,
hear
sir.
me?
Yes,
Good.
please, I can.
Okay, so let's do this, okay?
Okay, please.
So the first one is going to be, so where do you want us to start? Let's start with this guy, okay? So now it means
Okay.
that 1.65 times 1.65. What are we getting?
2.7225.
2.7225. Good. Times, now we have to do the subtraction first, okay?
Okay.
So 1 minus 0.5 will give us what?
0.5, please.
So then we can now come and multiply by 0.5, right?
Yes, please. 0.25.
And that will give us
0.25.
0.25. So it means that we are done with this guy. So now we can now divide by the margin of error, which is what? 0.03 squared. So it is 0.03 times 0.03. And that will give us what? What are we getting?
0.009.
So now
0.0003, please.
So it is 0.00.
009. Yes, please.
Okay. So now let's move on.
So 2 points.
So now we are going to multiply 2.7225 by 0.25. And that will give us what?
0.680625.
0.68.
0625 or
06.
06.
Okay. Divided by
0.0009.
0.0009. Uh-oh. I'm finding 09. And so this is equal to what?
756.25.
756.25. Good. Any question? Naomi,
yes,
you answer
sir.
the question, so well, you did it. So get ready.
Okay,
Get ready. Get ready. So Naomi, you can now call you lower your hand and call the questions. So this is how we do it. This one is very simple. When you don't know the population size, or probably the population size is very large enough, you can't even determine it. You can go by this method. Okay. So if you have any question how we computed it, please talk to us. You know, I'm sure people are okay now. So this one there. Oh, no question. Naomi, I think we don't have any question.
Okay, please.
Naomi is lakaba. And you see the Naomi na mama na the other guy, you talk again. Naomi the lakaba. Naomi, yeah, questions about. Let me say, Naomi brings a lot of luck here. So, my guy,
we have food here. We have food here.
Oh my Sharina Fubia, Naomi the lakaba.
The other one was more complex than this one. That's why. So the other one was more complex. The other one had a numerator in a numerator and a denominator in a denominator.
This one just say where you made it.
In the numerator square. Numerator and the numerator square.
Hey.
Hey, my you catch us me.
Hey, where you made it?
Yeah.
Naomi the lakaba. I think there's a hand up, you. Naomi, call that person and I think there's a hand up.
Please,
Yeah.
My answer.
Please speak louder. Speak louder.
7, 5. I said my answer had 756.255.
756 point what?
255.
Oh, Naomi answer here.
255.
So what's your problem?
If your answer is 756.25.
Naomi answer here. Naomi.
Hey.
Answer her. She's saying that we had 756.255 and she's getting 756.2. Is that yours is 2 what?
255.
Mine is 255.
And then we have 25.
Yes,
so now Naomi answer her.
Maybe I'm thinking maybe she added some extra zero somewhere.
Exactly. So the only problem is with the decimal places. So even if you run into the nearest whole number, don't forget that I said that we always have to run into the nearest whole number. You get the same thing, right? Okay. Now let's call the next person. Please, is someone giving us feedback? To what? Okay. I think we've answered you. Mary, okay. Mary, unmute yourself and talk.
Good morning, sir.
Good morning.
Please, with the second formula, you said when the population size is not given, that's when you go for the second formula. In a
It's not
case,
given.
yes, please. It's
Or you
unknown,
don't know.
sorry. It's unknown, yes.
Okay.
So in a case the population size is known, can you still go with the second formula?
Why not? You can go, but you need to justify. You know, I keep telling my students that research, you can do everything, but you need to justify why you are doing that. Okay?
Okay, so will you arrive at the same
No,
answer?
you not arrive at the same answer. How can you arrive at the same answer? Look at the formula.
Okay.
You not arrive at the same answer.
Okay. Thank
Okay.
you.
Okay. Now, I think we can move on to the next one. That one is very simple. Very, very simple. Okay. That one is very simple. Let's try that one. I think there's no hand. So Naomi, get ready and let's start. So after Naomi, then probably we take questions, okay? I think let me clear this. So the next one is very simple. That's what we call the Slovenes formula. Very simple. The Slovenes formula. And normally, you students, when they are doing their work, most cases, they prefer the Slovenes formula. Okay. And that one is very simple. And you can see that this one too depends on the population size. So if you have a population size, you can still apply this. Okay. So let's work on one. Vero, are you there? This time around, not be involved. So Vero, do this. Vero, are you there? Vero? Okay, Vero is not talking. So let me call my what's her name? No, Naomi. I mean Naomi. I was calling Vero, but Vero is not talking. So let me call Naomi. Naomi. Wow.
Mr. Naomi, please, you can unmute.
Okay, so she too is not talking. So let me call back to my brother. Edward, let's do it, okay?
All right, sir.
Let's do it. So now, it's very simple. The formula is given as the population size divided by 1 plus the population size multiplied by the margin of error. So the first thing is to do what? I think this is what we need to calculate first. 0.04 squared. What's the answer?
0.04. So 0.016.
Okay, so it means that we have 1 plus 2 brackets. Okay, let me take off the brackets. So it's 1 plus 240 multiplied by, you said 0.04 is what?
0.016.
0.016, right?
Yes, please.
Good. So now we can now multiply 240 by
it's rather 0.0016.
0. Yeah, this should be another 0. Okay. Now multiply 240 by 0.0016.
So you are getting 0.0384.
So now it means that it is 24. Please, I'm writing it down here. Okay. So it is now 240 over 1 plus, you said it's what?
0.0384.
0.0384. So now add it, and then we are getting 240 divided by 1 point what? 0384, right?
Yes, please.
Okay. So what's the final answer?
So we have 240 dividing. We have 6250.
The final answer?
Yes, please.
6250. Are you sure? 6250.
So I don't know. I think I'm using a phone calculator, so I don't know if that's giving me the right answers.
Oh no, I don't think that.
So I think there are a few rectifications we are supposed to make with respect to the.
Don't worry. Let's take your time. Let's start everything afresh. Okay. So now now I'm going to work this side first. Okay. Is that okay?
Okay, sir.
Okay. So now let's multiply this first. 0.04 by 0.04. What are we getting? That will give us 0.
0.002.
0.000 what?
0.002.
2.
2 zeros after the decimal place, then 2.
2.
Yes, sir.
Okay. 2. So let me deepen it. This is 2, okay? And so now we are going to multiply that by 240, okay? So what are we getting?
Okay, so multiply that by 240.
Yeah.
Gives us 0.48.
0.48. So it means that everything here is 0.48, right?
Yes, sir.
So now we can add the 1 to it. Do you agree with me?
Yes, sir.
So if we add the 1, that means we are going to get what? 240.
Sir, please.
Divided by what?
Sir, please, it's rather 0.384.
Which one is 0.3?
There is 0.0016 by 240. It is rather 0.384.
Okay. The 0. We said 0.384. No, come again. So what did you multiply to get the 0?
So I multiply 0.04 by 0.04 and I got 0.0016. And that's 0.0016 by 240 will give me.
And that will give us
0.384.
Who's giving that feedback? Someone is giving us feedback. Wait. Let's
So the person has been muted.
Okay, thank you. So it means that everything here is what?
Is giving us 0.384.
Okay, so 0.384 plus 1 give us what?
1.384.
1.384. So now divide and let's see what you get. Answer something. 7. What are you getting?
So we have 173.4104.
One what?
173.4104.
Okay, I think this is right. 173.410. I think this is right. Okay. Okay, so that's the final answer. So that means that if you run into the nearest whole number, what are we getting? We are going to use 173 individuals. Is that not it?
Yes, please. Yes, please.
Okay. So let's take questions, and then I would like to put across some information. Please let's take question. So let's go and see if we have the same thing in the slides. Okay, and that's true. So let's take the question, please. My brother, can you call the questions for us?
Mr. Clara Bema, please, you can unmute.
Hello, sir.
Yeah.
Sir, please, I would like to ask, with this one that we just did, you first said that we should always work in 4 decimal place. So I think that was the reason why Mr. Obin he converted the answer from
No
0.
problem. No problem. Once you're able to find the solution, I think that's fine. Thank you very much.
Sir, please, I wanted to know, like, if you convert it to 0.002, you get
Which
a different answer.
Oh, definitely, because you are running it. Once you are running it, that means that you keep increasing the figure, but the difference would not be so much.
Okay.
So normally when for exam's sake, when we are marking, we look at this stage. So
okay, sir. Thank you.
Oh God. Mm-hmm.
Sir, please, I would like to say something. Let us all not forget that Sir instructed us to always keep our answers in 4 decimal places. The mistake I did was that I tried converting from 3 decimal from 4 to 3. That was why I ended up with 0.002. So let us remember, don't convert it. Keep it in 4 decimal places so you get 0.0016. Then work with that. Then you get the correct answer.
Okay, that's fine. Any question on this? There's no question. Okay. So I want you to do something. Do you remember that I mentioned that the larger your sample size, the more accurate your work is? Do you remember that? Do you remember I mentioned this thing some time ago that if your sample size is large, the more accurate your work is? And if it is less, that means that the less accurate your work is. Do you remember that?
Yes, please.
Okay, so I want you to do this for me, Mr. Obin. I want you guys to, this time around, I'm not going to be involved. Everybody should do his or her own. But it's only Mr. Obin who may talk here. I want you to change this guy, the margin of error. You are using the same formula, but this time around, I want you to change this margin of error to 0.1. 0.1. So if you look at the 0.1, this is 10%. That means that this margin of error is more than the previous one. You agree with me?
Yes, please.
Okay, so now I want you to change it to 0.1 and compute, and let's see the sample size that you get. Do it right now. Let me hear from you. Have you guys finished? Okay, good.
Yes, please.
Okay, so now, Obin, what did you get? What did you get as your answer? Can I know what
Sir,
you
please,
had?
Obin is not on the line. It's Anani.
So Anani, okay, sorry. Anani, what did you get?
All right, so sir, please, I had 70.5882. And to the
So
nearest number, since we are using sample size,
okay.
I got 71.
71. And then the previous one, I think the previous one was what?
That was 173.
173. So if you compare this one, look at this one, this first one, and this second one, which one is larger?
Say the first one, the previous one.
The first, good. And you can see that one, its respective error associated with it is what?
The 0.04.
Okay, now the error associated with this one is what?
0.1.
0.1. So this one, if we are to compare them, which one is more accurate?
Say the previous one.
The previous one. And you can see that the previous one has what? More sample size compared to that of the current one. And that's the reason why I was saying that the larger the sample size, the more accurate your work. And so you can see that if you are doing your calculations, if you are doing your research, and you choose a small margin of error, that one will call for a larger sample size. Do you get it? And you choose a higher margin of error, that one too, it will call for what? A small sample size. I hope you are getting the point.
Yes, please.
Good. Okay, so if there's no question, I'm going to end the class. I'm so happy for the class today because I was expecting that this one would take a long, but you guys are so good. You guys are so good. You've really done well. I'm sure probably the video will also help, right? You've really done well. I really appreciate it. I wish today is Sunday. Yeah, I'll get time to go to church. Okay, so now please, any question? Any question? If there's no question, then I'm ending the class. But I will share with you. Please send me hi right now. Right now, as I speak now. Please send me hi the class rep.
All right, please.
And I'll share with you the next lecture notes. Okay. I can see a hand up. I think it's Edward. Edward is okay. So please send me hi. Edward, do you have something to say?
No, please.
Okay. So please send me hi right now so that I can share next week's lecture note with you. But that one, I don't know if I have video on that, but I'll check. I'll check if I have it. There's a hand. Joyce, I think Joyce, you can talk. Stop sharing. Okay. There are some hands here. Obin, please Anane, please can you call them the hands that we are seeing?
All right, please, Mr. Emmanuel. Please, you can unmute.
Thank you. So the example that you gave us for us to calculate it, I had 70.588. So does it mean that he ran it to 71 or?
Yeah, that's what we did. We said run it to the nearest whole number.
Okay. Thank you.
You're welcome. Next.
Mr. Deborah, please, you can unmute and talk.
Sir, please, I'm asking of the video. Please, can you place it on WhatsApp for us so that those of us, we are not having, we can have it.
Oh, contact your class rep. There's a link, then you can go to, it takes you there. So contact your class rep. But I don't remember what I'm going to share with him has the video. I'll check. Please, I'm still waiting for the hi. Nice. Just send it.
All right, please, yes.
Let me share with you right now before otherwise be an atiafas.
Dr. Adusei Bofa.
Okay. Hey. My sir.
Hey, sir, please, they are telling me that your number is not on WhatsApp.
Hey, which one? This is 055 or 026?
Yeah, the 055.
Yeah, the 055. I stopped using it. Someone tried to hack my number. So use the 026. Do you have the 026?
No, please, we're giving only the 055.
And so that one, see me backline. But if I give it out, it's become public.
Sure, sir. I'll do that.
Everybody. So you can call me right now and let me give it to you.
All right, sir. Let me call you.
Okay.
Sir, I've sent you a message on that number. I sent you a hi. So you can forward it.
Okay. So don't worry. Okay, so let me just share it. Yes, who is that? Okay. Do you have it?
Say yes, it has been received.
Okay. So my boss, you can take it from Gregory. he just sent. So you
Yeah,
can take the
so
number from him also.
this okay. This even with this one, you sent it to me earlier, so I've even given to them already.
Oh, okay, so you
Is
have
it
it. Okay, that's
is it
fine.
the one you intend to send? Because you sent it to me 2 days ago, and I've put it in our
Oh,
group
okay,
already.
okay. That means you already have it. Okay, that's fine. That's fine. So that will be for next week. Okay.
This is for next week.
Yeah, that's for next week.
Yes, sir.
So God willing, we will use this one for next week. Okay.
Okay, sir.
Okay. All the best. So take care of yourself, and God be with us all. So we'll meet next week. Okay.
Right. Thank
Yes,
you,
sir.
sir.
Thank you very much.
Okay. Don't
Bye.
mention. Bye. Or do you still need any questions? If there's no any questions, please can I leave?
Sir, please, I saw a hand. I think Mr. DJB.
Okay, so let's hear from Let's hear
Please,
from
Mr.
you.
DJB, I think I saw your hand up. Please, if you still have your question, kindly come on board. Sir, please, I think he's not coming.
He's okay. Is he okay? I think
All
the
right,
hand
sir.
is up again.
Yes, please.
So let's hear from him.
Mr. Charles, please, you can unmute and talk.
Yeah, sir, please, I want to ask the video. We are on the page since the day you said you will be giving it to them to put it in the page. We've not seen anything of that sort in the page.
Don't worry, you get it. Don't worry. Okay. Don't worry. They will sort you out. Okay.
Okay,
Don't
sir.
worry, you get
Thank
it. Okay.
Now medicine a cheat a year video that you are years how video no one. Well one. Most of your videos my how video say about I don't know we and man for this how video nine.
Myself, or they keep it to themselves.
Hey, you people take your time, please. Take your time.
So I would like to inform the whole class that the slides for what we did today, and then that which we are going to do next week. The slides for what we did today and last week, they were sent. You sent it to me earlier in the morning on Saturday, and then I posted it in the group. So everyone in search of that slide, you go to the Oseko page. For last week's chat, that was on Saturday, I posted it around 6 a.m. even before you came around for the lecture. So for those of us looking for that, you can go back to the WhatsApp page. The messages we sent last week is there. And then the ones that are for next week as well, which you just sent to me, I gave it to them 2 days ago. It is all in there.
Imagine. So
I
people may
don't know
think that.
what they
No, I
mean when
think
they
the
say we are
problem is.
keeping things to ourselves.
I think the problem is probably I sent it earlier, so they think that it should just come as I teach. So they miss it out. They find themselves wanting, just miss it. So please, you just have to pay attention to the messages, okay? I think that's the problem. Okay. Okay, so all the best. And then as I keep saying, please take care of yourself and God be with us all. So God willing, we'll meet next week, okay? Bye-bye.
Okay, sir.